Hello and welcome to the Repairing Aluminum Intensive Vehicles webinar. I'm Krista McNamara, Managing Editor of ABRN Magazine, and I'll be your moderator today. With aluminum continuing to gain popularity among vehicle makers, it's more critical now than ever to understand the unique considerations around working with aluminum structures. So today we have with us Jeffrey Poole, Performance Training Coordinator with ICAR. Jeff will discuss aluminum characteristics and proper electrode wire and rivet type and lengths, straightening considerations, removal and installation procedures, and attachment methods among differing vehicles. I think most of us know that the ICAR vision is that every person in the collision industry, current and future, has the necessary knowledge and skills relevant to their position to achieve a complete and safe repair. So now getting back to the topic at hand, Jeff, the use of aluminum is on the rise in the industry. What does this mean for us?
Thank you, Krista. We appreciate the opportunity to work with ABRN on the webcast. Throughout the history of vehicle construction, we've witnessed aluminum used in varying degrees. The use of this construction material lowers the vehicle weight. This equates to greater fuel economy. With the continued increase in corporate average fuel economy requirements that the vehicle manufacturers are facing, they're working very aggressively to meet this challenge. Alcoa Aluminum has expanded its Iowa facility. This is primarily due to the rising demand from vehicle makers. Company representatives stated that expansion is for business that's already been secured. Other aluminum manufacturers are expanding as well. Current aluminum structured vehicles are, for the most part, luxury or performance oriented. There is a continued increase in the use of aluminum for body parts, hoods, closure panels, doors, and other components on non-aluminum structured vehicles. Whether it's an aluminum-intensive vehicle, meaning almost the entire vehicle and structure are made of aluminum, or whether it's a hybrid construction where there may be some aluminum mixed in with steels in the body composition, the message is very clear. Whether it's a cosmetic panel that we're repairing or aluminum structures, we can expect to see more of this in the future. Aluminum is in our future in the repair industry. So let's take a look at some of what we need to know regarding this as we move forward. The benefits of aluminum are directly in the weight savings. Aluminum has a natural corrosion resistance much higher than steel. It forms an oxidation layer naturally. This is beneficial in some regards. It can also be a repair consideration as we go through and we look at some of the repair procedures. Predictable collision energy management is another benefit that we have with aluminum. It's highly recyclable as well. From a manufacturing stance, the vehicle manufacturers need to look at some of the considerations there, cost of aluminum so far as the raw material, and the changes to the assembly line, fastening and joining methods. We're at a really pivotal point in the automotive industry where fuel economy requirements are in the driver's seat.
Jeff, what can you tell us about the strength of aluminum?
Pure aluminum in and of itself is relatively soft and ductile. So what they do is to produce a material with beneficial properties, other elements are mixed in, formulating different aluminum alloys. These aluminum alloys can be designated anywhere from 1,000 series to 7,000 series. There are literally hundreds of sub-alloys that live under each of those categories, and also be aware that castings do use a different designation sequence. This alloying process, it affects the strength, formability, corrosion resistance, and weld properties, as well as some other attributes. Some of the alloy series can be heat treated to further increase strength. This can be a consideration in the repair process. There are also temper designations, where, again, this is something that we need to understand. It affects the strength, and we may see an H as part of the designation for a strained hardened alloy, or a T as part of the designation for a thermally treated alloy. Aluminum alloys, in a basic analogy, can be likened to making a loaf of bread. Different people can make different loaves of bread. They put different ingredients in. They bake it for different amounts of time at different temperatures, and the end result is a loaf of bread with different flavors, different textures, different properties. Some of the aluminum alloys, strength-wise, are on par with some of the high-strength steels that are out there in vehicle construction. It's ultimately the vehicle engineers that determine the properties required, and ultimately the different components in that vehicle and the alloy selections that go along with it.
Now we'd like to ask the audience a polling question about their repair habits. You can respond directly online right on your screen. So our question is, how often do you repair aluminum-intensive vehicles? Please select one of the following answers: weekly, a few times a month, no more than once a month, a few times a year, never, or I don't work in a collision repair facility. Also keep in mind throughout the presentation we will be accepting questions to be answered at the end of the presentation. If you have any to submit, please utilize your Q&A tab at the bottom of the screen. Okay, so now we're going to take a look at the response. It looks like a majority of our respondents answered they repair aluminum-intensive vehicles a few times a year, with 21% of our respondents, followed with about 15% who repair them a few times a month. Okay, so Jeff, now there are some different manufacturing processes when working with aluminum. What are the different characteristics in these processes?
As we take a look at vehicle construction with aluminum, we're looking at either cast aluminum components, extruded aluminum components, or stamped aluminum components, or some combination thereof. And in some cases, we may have vehicle construction that only has extrusions and stampings and no castings, or some other combination. So we'll take a look at each one of these individually to have a better understanding of what the implications are of each. First one we'll take a look at is the stamp parts. Now, these are generally identified by a part that's a relatively uniform thickness. We're looking at a stamped sheet metal part made of aluminum. They typically have flanges for attachment. May have stretch marks or areas that seem to be gathered from the forming process. This is generally on the underlying sheet metal components, not the exterior sheet metal of the vehicle. The exterior sheet metal will have a more refined finish. As we look at the stamped components in aluminum on the exterior of vehicles, again, fenders, hoods, and doors on some vehicles, we're looking at those going to aluminum composition. So far as aluminum structured vehicles, the stampings can also be used for body structural components, rails, pillar components, cross members on those aluminum-intensive vehicles. The stamped aluminum parts are generally going to afford the most repairability when compared to extrusions or castings. So when it comes to repairability, the stampings are going to be the more cooperative, if you will. Taking a quick look at extrusions. Extrusions tend to be a stronger component, and we'll look at how they're made. Some of you may have kids or grandchildren that have played with the Play-Doh Fun Factory, and they put the Play-Doh in and they mush the Play-Doh out through the different dyes, and they form different shapes. And that's essentially the basis of the extrusion process with aluminum. They press heated solid aluminum billets through heated dyes, and this allows some pretty complex design. Some of it can be pretty basic and straightforward. Looking at the photograph on the screen there, the upper left hand is a depiction of a traditional steel construction vehicle where we have an outer rocker panel identified by the yellow component, an inner reinforcement perhaps identified by the red, and then the inner rocker panel identified by the green. Three different pieces coming together in the manufacture process and on the assembly line to form that rocker panel. Whereas if we look at the photographs below, we can then see a typical rocker panel component for an aluminum structured vehicle that is one piece, and thereby streamlining some of that process. This also takes in with the internal wall structure, gives that part greater strength properties. Can present some challenges on the other side as well so far as repairability. As we get damage to that component, it may limit what we can do with it so far as straightening or repairing. So extrusions can be single cell or multi-cell. A single cell extrusion is representative of what we see in the photograph on the upper right-hand side. That's a Corvette frame rail. And this is something that is basically hollow inside, whereas a multi-cell or multi-wall extrusion, you can see by the internal wall structure where it gets its name. Extrusions do have limited repairability due to the accessibility and the complexity of the inner wall structure if it's a multi-cell. Some examples of some extruded parts that we see on vehicles out there, rocker panels, roof rails, pillars, and frame rails. Extrusions are typically serviceable, and depending on the application, there can be recommendations for sectioning, partial replacement of factory seams, replacement of only the damaged cell, or full part replacement. Taking a look at the next component, castings. Castings are created by essentially pouring or injecting molten aluminum into a mold. This can then produce a variety of shapes and thicknesses, as well as cross sections can be made. The castings are typically attached to other parts with MIG welds, or may use bolts or rivet bonding. Vehicle body construction castings can be used as joints where multiple parts come together. These are called cast nodes, kind of like building blocks for the vehicle. They may have extrusions coming into castings. They may be attached to other extrusions, or they may be attached to stamped parts, or whatever the vehicle manufacturer desires to do. Strut towers and pillars, as well as suspension parts and mounting locations, are an example of where we can see castings used in aluminum body structures. We're seeing, in some cases, some of our steel-structured vehicles out there with cast strut towers in order to afford some of that weight savings and get weight and balance distribution in the vehicle for better handling characteristics. Castings generally have a rough, textured surface and irregular shapes. They can also have machined surfaces and tapped holes. For the most part, damaged castings should be replaced. This may require reattachment using bolts, rivets, or rivet bonding, or possibly some sort of a welding process, MIG welding. There are some repair procedures for threaded attachment points that are damaged on some castings. It's really critical whenever we're dealing with these components that as we're putting fasteners in, we are using a torque wrench. Stripping out a threaded fastener location in an aluminum part is not going to be a good day at the office.
Now let's talk about galvanic corrosion and some of the considerations there.
I'm sure many of us can, I want to say, turn back the hands of time a little bit and think back to a vehicle that we saw in the past that had a bumper that was rusting off of the vehicle. And there were a number of vehicles that had chrome steel face bars and they had an aluminum backer on them. And those vehicles over time, perhaps if technicians serviced that bumper assembly, they didn't put that little plastic barrier in there that came in the original assembly of the vehicle. And those things would just rust like crazy and they'd literally fall off the vehicle. So that was a real prime example of galvanic corrosion. It takes an electrolyte, some sort of moisture that's not pure water. Pure water is not an issue, but we don't have much pure water in the environment. Essentially, galvanic corrosion occurs when dissimilar metals are in contact with each other and there's an electrolyte present. We then get a chemical reaction that happens, and it's actually forming a little battery in there where there's current flowing. And when current flowing, that means electrons are moving, and that's breaking down the material. So during the manufacture of the vehicle, steps are taken to minimize this occurrence. And this may include the use of specially coated fasteners, various coatings and sealers, or adhesives between the panels. Non-conductive urethanes may be called for on glass installations. These are things that during the repair process we need to make sure we keep in consideration.
Jeff, can you tell us a little about work hardening characteristics and heating considerations?
Anytime we're out to repair anything, we need to understand it. We need to have a basic fundamental understanding of operational principles and how it responds and reacts. And work hardening is one of those key elements there that we want to make sure that as we're making repair and replace decisions, we understand the properties of this material we're dealing with. Aluminum has a high rate of work hardening. Each time it's work hard, it becomes increasingly brittle. And this may lead to it cracking whenever it's damaged or perhaps during the repair process. This really varies by alloy, thickness, and the manufacture method. So just for an example, I'd like to discuss a stamped part. A stamped part, for example, during manufacture, as the sheet of aluminum is being processed, it's pressure rolled to thickness. This work hardens it, and they know that whenever they manufacture what its characteristics are going to be whenever it comes off the press, as it were. Then that is then stamped into the shape of whatever that part happens to be. During that stamping process, that further work hardens it. Whenever the vehicle's in a collision and that part is damaged, that additionally, as it gets deformed, that additionally work hardens it. And then during the repair process, we have to work the material to restore it. Heat can help reduce the tendency to crack, but is not always going to ensure success. So if you take a look at the photograph on the screen there, that's an Audi A8 rail extension for the front. And there's a casting that affixes on, and it's welded on from the factory to an extruded tube. And it is a sacrificial component on that vehicle. That casting, as it gets damaged, it's going to be very prone to cracking. So again, something to keep in mind. Let's take a look at heating guidelines next. Some of the heating considerations, and I got to throw a disclaimer in here. Always follow the vehicle manufacturer guidelines regarding any repairs to the vehicle. There may be certain statements prohibiting repairs and or the use of heat during the repair process. approaching the topic of heat on a generic level. Minor damage to stampings and extrusions may be repairable cold. The work hardening, though, is the thing that we're kind of challenged by. And what we know is that using heat within reasonable limitations, reasonable guidelines, can assist in allowing us to move those molecules back where they should be and reduce the tendency to crack. No guarantees here, but it is something that will help increase your chances of success. So if heat's being used, let's make sure we identify any recommendations or guidelines that there are. As a general rule, we do not want to exceed 450 degrees Fahrenheit. That's your absolute maximum. Now, there's a property called annealing. Annealing is something that happens to metal whenever you take and you heat it. Beyond a certain temperature, it'll permanently soften or change the properties of that material, and we're just not going to get it to go back where it was. For most of your aluminum alloys, annealing temperature start at about 650 degrees and go up from there, again, depending on the alloy. So the 450 degree and below is a safe area to live in. I know several aluminum structural technicians out there that say, we take it to about 350. We find that we make reasonably good progress there, and in most cases, if that won't do it, it's probably too badly damaged, and it should be replaced anyways. So we want to make sure we also monitor that heat. That's very, very critical, using temperature sticks, paints, or non-contact digital thermometer. Those non-contact digital thermometers, you need to have that adjustment for emissivity, for temperature correction based on the reflective color temperature of the material that we're using. So again, things to keep in mind as we're going through there. Time is not so much a consideration when heating aluminum as temperature is.
Why don't we discuss some of the vehicle design and damage analysis considerations?
As we take a look at the design of the vehicle, again, we need to understand how is that vehicle going to respond to collision energy? Where was the impact? Where was the damage? And following that energy into the structure of that vehicle is very important. Aluminum-intensive vehicle structures may be designed on architectures such as a space frame or a unibody. They may call it monocoque construction, or maybe it's some sort of a hybrid structure where there's steel and aluminum that are used in that vehicle body structure. It's important to keep in mind during damage analysis and repairs as we're going through, the load paths in the vehicle structure are going to manage and transfer that collision energy based on that design. And we need to understand, okay, so what's happening? And how does that resonate through to the structural repairs as we're performing the structural repairs on that vehicle? So when it comes to damage analysis, when developing a repair plan, in addition to the typical visual damage indicators that we're looking for on your vehicles, we want to pay particular attention to the joining areas. Adhesive and rivet bonded joints may not give the appearance of damage, but extremely close visual inspection is necessary to ensure that damaged bond line does not get missed. When a vehicle is in a collision and that structure is taking that energy, there's a lot of shock that goes through that structure. And again, it's going through each one of those joints in there. The condition of fasteners can be clues. Rivets, bolts could be sheared off, or there could be gaps or separation between panels or fasteners in the part. Again, we want to make sure we're doing a close inspection of all those areas and adjacent parts. Inspection of welded joints is important as well. Again, as that collision energy travels through the different parts of the vehicle structure, the extrusions, stampings, and other components may give or flex differently depending on their makeup than the adjacent parts. And this has the potential to put a lot of stress on welded areas especially, and can cause cracking of welds. Use of dye penetrant may be called for to help find cracks and damaged parts and repaired areas as well, parts and the weld beads.
Let's move over to measuring and straightening considerations.
When it comes to measuring, we need to understand where are we and where should we be. Where is that vehicle and where should it be? So as we look at measuring, this is really one of the foundations. It's a vital ingredient utilized during damage analysis and during the repair process so that we can truly document the damage in that vehicle and the repairs that we've done. The build tolerances of today's vehicles are impressive. Three-dimensional measuring is critical. This may include the use of universal or dedicated fixture systems or some sort of a three-dimensional mechanical or computerized measuring system. But I can't stress three-dimensional measuring enough. There may be limited data available for some of these vehicles, and by the nature of the dedicated fixture systems, they measure that vehicle and position the parts correctly as we're going through the repair process. We want to document the damage and document the repaired vehicle. Print and save your measurements to the RO file. Can't stress that one enough. When it comes to straightening, there is no general rule whenever we're attempting to straighten aluminum. It doesn't want to go back. It's not real cooperative. Aluminum has a very poor memory, and it resists straightening attempts. So when we're evaluating what may or may not be repaired, we really need to ask ourselves some questions. And experience really pays dividends here, and this is where we've got a learning curve ahead of us. There are many shops out there that specialize in aluminum-intensive vehicles and technicians out there that specialize in aluminum vehicle repairs. And that experience that they have really helps them understand to a better degree what's their success rate going to be whenever they're looking at a given damaged part. Part thickness and alloy are considerations in repairability. Is the part a stamping, a casting, or an extrusion? That's some of the questions we need to ask. The thicker the part, the harder it's going to be to straighten. We don't have a kink versus bend rule that applies to aluminum components. We may find during the repair process that we have to do some slight overpulling and stress relieving, very similar to what we do on steel structured vehicles to help account for that spring back that may happen. We want to monitor our pulls as well. Again, keep an eye out for induced damage to adjacent panels and joining areas, as well as keep a good eye on our anchor points just to make sure we're not creating any additional work for ourselves.
Now we'd like to do our second polling question that, again, you can respond to right on your screen. Do you have a designated aluminum repair area in your facility? Please select one of the following responses: yes, no, or I don't work in a collision repair facility. Again, that's do you have a designated aluminum repair area in your facility? And please answer yes, no, or I don't work in a collision repair facility. And just a reminder, any questions you have, you can submit using the Q&A tab at the bottom of the screen. Okay, so let's take a look at our answers. It appears that the majority of our attendees today, with about 56%, don't work in a collision repair facility, and about another 36% do not have a designated aluminum repair area in their facility. So now we're going to take a look at how working with aluminum differs from what we may be accustomed to with steel.
When it comes to part replacement, there's a few items we need to consider regarding cutting, drilling, and grinding. What we find with aluminum is that drilling and cutting can generally be done at high speeds. This is something that we want to be sure to use sharp tools, and there may be recommendations to use a lubricant. Now, if you are using some sort of a lubricant to help minimize clogging of the cutting tool, this is something that then we'll have to make sure we get cleaned up properly before panel reinstallation comes into play. The rotary files that are used for aluminum are much more aggressive than the ones that are used for steel. And if you use the ones that are manufactured for steel, you'll find they clog up and you've pretty much ruined them. So go with the ones for aluminum, but keep in mind they are extremely aggressive, and they tend to get the job done pretty efficiently. You can also dig into your skin pretty quick if you're not careful, so take care. All sanding and grinding should be done at lower speeds with lighter pressure, and that helps to minimize clogging of the abrasive wheels and or heat buildup. It's also something that's real important to keep in mind that any of the abrasives, cutting tools, and things of that nature that we're using, we need to make sure that they're not contaminated with other materials. We don't want to bring in contamination. For the most part, the abrasives and cutting blades should be dedicated to aluminum, and any of the tools that are used need to be clean of any potential contaminants. I know many of the repair network situations out there require that you have dedicated tools and equipment for the vehicle repairs.
Let's take a look at OEM part attachment methods and some considerations for attachments in the repair process.
The vehicle manufacturers can draw from a variety of attachment methods. This may include mechanical fasteners like bolts. They may use rivets or clinches or flow drill screws. They may use hemming processes or adhesives or welding or any viable combination thereof. In some cases, we may have the ability to reproduce the original installation. In other cases, it may call for some alternative installation method in the repair sector. So, taking a quick look at some of the repair fastener considerations. This is something that we want to do early on. Whenever we're doing our damage analysis on that vehicle, blueprinting that vehicle, we want to make sure that we are identifying the correct repair methods and fasteners so that we can really ask ourselves the hard questions. Do we have the tools and equipment it's going to take to repair this vehicle correctly? Is this something that we need to get, that we're going to make the investment in, or should we make a different decision on the repair of this vehicle? So it's really critical to identify those repair methods and fasteners. In some cases, this may include duplicating that original installation, or there may be alternative installation methods specified. So we'll take a closer look at some of these as we progress forward. The clinch is I'm going to call it a non-structural fastener. It's used on mostly cosmetic panels. I know there may be some folks out there that disagree with that slightly, but for the most part, where I've seen them used are on hoods and deck lids and perhaps a quarter panel skin to a rear body panel or a floor extension flange on a vehicle. Mostly these are used in areas that are not outwardly visible on the outer sheet metal of the vehicle, although when you open the hood you might see them, or open the trunk you might see them. A clinch is essentially just like a soda can tab. You use a die and a press at the factory to take and draw the metal through itself, and it takes and locks that metal together. This is something that we do not have equipment available, at least not that we're aware of, to the repair industry that can reproduce a clinch. In situations where we've seen clinches called for replacement, we find that generally rivets and perhaps a bonding procedure come into play on those applications.
Now we're going to take a look at some of the other fastener considerations and things we need to be aware of.
Bolts are an important piece of what holds a vehicle together, and sometimes we don't think about them as much as perhaps we should. As we take a look at the bolts used in vehicle construction, and especially where we've got mixed metals content, we'll find that generally with a bolt there is a coating that's baked onto that fastener at high temperature whenever that fastener is manufactured. This is not a coating that there's a brush-on replacement for. So this is where, as we're disassembling that vehicle, we want to make sure that we're identifying any fasteners that potentially need to be replaced, fasteners that have damaged coatings, things of that nature. As I talk with technicians on this, I said, I hate to be the next guy that has to take that car apart. That could be a rather interesting challenge there, or the next technician. So we may find that some of the features indicate replacement, one-time use fasteners, as it were, replacement of the bolts if they're loosened or removed. In other cases, it may be acceptable to reuse them, again, if the fasteners and coatings are still in good condition. Take a look at an example here real quick. If we're installing a bolt on a part and the fasteners are one-time use, let's just make believe we're putting a fender on a vehicle, and you've got one-time use fasteners. Essentially what you want to do is plan out during your repair to have those bolts on hand when that vehicle is going back together, but don't use the new bolts initially. Put the fender on, install the old bolts. Get it lined up, because if you have to loosen and tighten as you make the adjustments, you want to make sure that you're not doing that with your brand new bolts. So you may only have to use a few bolts to hold it on and get it lined up. Then at a point in time where you're comfortable with the fit of the panel and you're saying, okay, I'm done, you're going to take the new bolts and put them in one at a time, torque them to specification, and you're done. So again, in the repair planning and follow through, this is a critical element there to make sure that we're abiding by the guidelines. Careful inspection and attention to detail is going to be real important as the vehicle is disassembled, as I've mentioned. Again, make sure you've got the right fasteners on hand when it's time to put the vehicle back together to keep things flowing. Torque wrench. You have one on hand? Is it calibrated? Question you might want to ask yourself. Rivets. There are a variety of different rivets that vehicle manufacturers are using, and a variety of different rivets that are specified in some of the repair procedures. Some of these present some unique challenges as the tool and equipment requirements are very unique. We may have solid rivets or blind rivets or self-piercing rivets. It's really critical, again, that we identify the correct type of rivet as well as the correct size for the application. This really depends on the procedure, the panel stack thickness, what are we dealing with in that regard, and as we look at the specific tool and equipment requirements, again, do we have these on hand? Do we have these? Some of the repair rivet bonding procedures are going to be utilized in place of welding, so we may find that bonding comes into play there. As we take a quick look at some, we see these used by certain vehicle manufacturers in the build of vehicles. We also see where they're called for in some of the repair procedures on aluminum vehicles and on at least one occasion on a non-aluminum structured vehicle in some of the repair procedures. So as we look at that SPR a little bit closer, self-piercing rivets are made of coated steel. And again, they're utilized by some vehicle manufacturers instead of spot welds. Removal methods vary by manufacturer. They may recommend grinding them out. Now keep in mind, if you're on an aluminum structured vehicle and you're grinding and you've got steel rivets embedded in there, you're now grinding through and you've got steel shards, steel pieces going everywhere. And so cleanup becomes another piece of this where we make sure we've got some sort of dust extraction and that's appropriate for the aluminum mix that we have there. That's another arena that we start thinking about some of the depths of aluminum and safety, where you're sanding and grinding and doing things of that nature, and you've got aluminum and other materials. You get the right combination of different stuff going through your dust extraction system. You could have an exciting day at the office if the stars and the moon line up quite right. So it can be explosive results. I'll leave it at that. So those self-piercing rivets, removal may include that grinding, drilling, or pressing, or maybe even a special stud welder tool. And again, the installation is going to require the correct press and dies to put those rivets back in if it's called for.
Jeff, tell us about bonding and any unique preparations that may be required.
We see adhesive bonding being used in so many vehicle build applications these days, and it's becoming a very, I want to say, a big part of the repair process. The confidence in adhesives is impressive. I'll word it that way. One thing I want to throw out there real quick when it comes to any operations we're doing in the shop environment, we're hopeful that your compressed air in your shop is clean. I know that for the most part we've got excellent filtration on the booth where the spray operations are happening in the paint department, and in most cases shops have good clean air going to the technicians that are performing the repairs. But each time we take and we use our air blower to dust off the surface, any potential contaminants that are in our shop air supply are coming out and going onto that surface. So it's really, really critical that our shop air supply is clean when it comes to all of our preparation steps. So we'll move on to those adhesives here. When it comes to the complexities of today's repairs, the use of adhesives, we want to make sure we're following all the correct flange and material preparation steps. You can't skip anything along the way. If you've skipped any step along the way, you might as well just not use the adhesive. It potentially voids the bond, if you will, of that adhesive. Again, this is another area where there's some unique requirements. We want to make sure we understand the surface preparation steps, the surface cleaning, abrasion if that's specified. Some cases it may be and it may not be in other cases. We may have different grit specified for surface preparation. Again, our material, our cartridge preparation, the installation of the mixing tube, purging the cartridge, and the application. Getting that part aligned, getting it clamped and installed, having all of our fasteners on hand so that we can get that panel set into place, aligned, and set within the adhesive working time. We have to take all that into account. So again, critical planning up front before we open that adhesive and start putting it on the surface. We want to make sure that vehicle is restored cosmetic and structurally. All parts, tools, and equipment and fasteners on hand, organized, ready for the installation. The vehicle structure is aligned. The surfaces are properly prepared. Oxidation removed if we're working with bare aluminum. And once you've removed and prepped that surface, you can't go home. It's time to finish the job. We need to get that adhesive on there. We need to get that panel on there. We need to get it set into place. Have our replacement part surface prepared. Have our surface conditioners, adhesion enhancement treatments, or flame treatments, or whatever's called for the procedure. We need to get those in place. Then we get our adhesive cartridge prepared, the adhesive applied, get that panel and parts installed, aligned. Once we get it in place, we want to slide it. Don't lift it to reposition it. Then once we've got our panel aligned, then we have to install our fasteners or get it clamped as appropriately. To make sure that panel is in correct flushness before the adhesive starts to set up. You may find you have some interesting challenges ahead of you if you don't. Once the parts are installed, it may require the vehicle to remain in fixtures for a period of time while the adhesive sets up. Kind of curious how many folks out there do bond panel test samples, something you might want to consider. Very recently, ICAR updated the ADH01 course. Effective June 24th of this year, this course will include new demonstrations that enhance the class experience. I think the technicians are really going to love it.
Now it's time for our third and final polling question. Do you have welding equipment suitable for aluminum welding? Again, please select one of the following responses on your screen. Yes, I have a traditional MIG welder with a spool gun. Yes, I have a MIG welder with pulse capacity. No, I don't have aluminum welding equipment, or I don't work in a collision repair facility. Again, the answers are yes, I have a traditional MIG welder with a spool gun. Yes, I have a MIG welder with pulse capability. No, I don't have aluminum welding equipment, or I don't work in a collision repair facility. Okay, again, it looks like the majority of our respondents have replied that they don't work in a collision repair facility, but of those that do, about 20% do not have aluminum welding equipment. So, Jeff, now what do we need to know about welding aluminum? How is it different from welding steel?
Folks that know me know I love to weld. It's therapy for me. I'll word it that way. During repairs, we may find it necessary to utilize MIG welding. I will make a quick brief statement. For the most part, we do not see TIG welding used in the repairs of today's modern vehicles. There are concerns with that welding process. It does present some challenges to the average technician to be able to professionally TIG weld, as well as some safety concerns for the electronics on the vehicles. MIG welding has been widely accepted by many of the vehicle manufacturers where they call for welding processes. What we find is generally it is a pulse-type welder that they call for. There may be some very unique requirements so far as equipment goes. I'll delve into that a little bit later perhaps. But as we take a look at the welds themselves, we're typically looking at doing some plug welds or fillet welds, or perhaps a butt joint with backing type joint configuration, or maybe an open butt joint. Shielding gas selection, the electrode wire, diameter, the equipment setup, along with the skills of the technician to make those welds are some of the ingredients that we really need to focus on. Pure argon is the shielding gas to be used whenever we're doing the MIG welding of aluminum. There are different purity designations, so be sure that you select and receive the correct one. At one point in my career, we got a bottle of shielding gas that unfortunately wasn't so pure, and thankfully during the test weld process, I identified that, hey, we're getting porosity in here that just isn't going away. Let's go exchange the bottle, and got a new bottle of gas, and we didn't have that issue anymore. So it was good that we didn't experiment on the vehicle. We were experimenting on our test samples, and we found we had an issue. The electrode wire selection is critical to achieve a strong weld. This electrode wire is going to mix in with the base metal alloys in the weld puddle, and then it reformulates. The incorrect, if we choose the wrong electrode wire, this can result in undesirable weld composition and a weak weld or a weld that cracks. In some cases, you may find you're joining two different alloys with yet a different electrode wire alloy as the prescribed repair for the vehicle. So again, we're not the chemist per se. We just want to make sure that we're looking at what the doctor ordered so far as the repair. Correct surface preparation and consistent joint fit up. These are mission critical. The oxidation's got to go. We cannot have any oxidation, front or back, within a reasonable distance of that weld. No coatings, no weld-through primers. We want this to be a surgically clean environment during preparation and execution. Again, I can't stress the necessity to make practice welds enough. You should have some scrap metal from the damaged parts that have been removed, or spare metal from the service parts, to take and practice and tune your equipment and your technique. If you're welding in the overhead position, you need to practice and get that machine and yourself tuned up in the overhead position. I know it's no fun when the sparks are falling on you. wear your safety equipment, get your respirators, your safety glasses, your welding helmets, your hoods, your jackets and gloves and everything else on there. And I know it's hot out in the shop in the summertime, but you need to get those welds the first time on the vehicle 100% right. When the weld's initiated, what we find is that progression is not as uniform as when we're welding steel. Aluminum has a higher propensity for cold starts, and our techniques to take and minimize this. Additionally, the travel speed is usually faster than we're accustomed to with steel. As the heat builds in the material, we find that the travel speed is going to change, penetration changes, and the potential to burn through increases. So judging the weld puddle tends to be a little more challenging because it is a more fluid weld puddle than typically with steel. So if you're not careful, we end up with a crater or a hole in the panel. Perhaps some of you have attended and gone through the aluminum welding qualification. Congratulations to those of you that have. This is a hands-on automotive welding qualification that takes a look at the instruction, practice, and testing for welds used in the repair of aluminum structured vehicles. It is required by some of the OEMs.
Now let's take a look at vehicle-specific training.
A number of vehicle manufacturers have training and equipment requirements for authorized shops. This really addresses the unique repair aspects pertaining to their vehicles. A couple of examples that I-CAR is involved with, Jaguar and Chevrolet on the Corvette Z06ZR1. This is conducted by I-CAR at the Tech Center. There's a host of additional information and details that you really need to be aware of. This presentation really just starts to scratch the surface. Some of the additional considerations may include dust collection, ventilation, dedicated tools and equipment. There's so much more beyond that, though.
Jeff, why don't you tell us a little more about the ALI-01 training from I-CAR?
When the Aluminum Intensive Vehicle Repairs course was developed, we set out to build a course that was different, something that was more interactive, something that was more engaging, something that was more fun. Mr. Jeff Silver provided some insight to our technical team on this, and I'd like to say thanks, Jeff. We appreciate it. Jamie Betcher is our instructional designer behind this course. Some of you that have been to the Tech Center for some of the OEM-specific contract training have probably worked with Jamie at some point in time. Aluminum repair is not difficult. It's just different. And the course, ALI-01, it's different. It's not difficult. It's a fun course. We increase the interactivity among the students by utilizing group activities. Throughout the class, the students are going to make repair decisions on simulated vehicles. They're going to work in repair teams. Each team, each group is going to follow the flow of the technical topics in the course. They're going to apply what they've learned to their collision-damaged vehicle as we go through the course. They revisit the activity periodically. They build their repair. And then they share the outcome of their repair, how they decided to repair their vehicle at the end of the course with the rest of the group, hopefully bringing a better understanding and a better retention of what they've done, making this more true to life, true to shop, scenario-type learning environment. For those of you that are interested in or are already following the I-CAR Professional Development Program, the course applies to the structural roles for steel and aluminum, also applies to estimators and auto-physical damage appraisers. If you'd like more information on the training, you can certainly contact I-CAR Customer Care at 800-422-7872 or the I-CAR website for more information. When your customers test the repair, are they going to perform? What's the outcome going to be? Hopefully a complete and safe repair is your goal every time. We'd like to help you achieve this.
Now we'd like to take this opportunity to solicit questions from our viewers. If you have a question to ask, please type it up and send it to us through the Q&A tab at the bottom of your screen. So Jeff, for our first question, what types of welding equipment features and capabilities should shops look for when working on aluminum repairs?
I always ask more questions about what their specific direction is before I go into any specific recommendations. And as I-CAR, we don't recommend specific equipment per se. We'll look at the features, definitely pulse MIG. Aluminum can be welded with a traditional MIG welder with a spool gun setup. I've even pushed aluminum wire through a traditional MIG welder. It's very challenging because of the issues of burn back and bird nesting and things of that nature. The first major question I ask is, are you looking at some sort of an OEM relationship here? Because if you are, then you really need to take a look at any specific or unique requirements that they have so far as the equipment goes. I will say that some of the equipment out there has some very advanced capabilities, and there's a pretty steep learning curve whenever you initially get that equipment. You certainly want to be prepared to dedicate some time to learning about all the capabilities of that equipment and the functionality of that equipment, because it can be a little bit intimidating at first. But initially, as you're looking at equipment, definitely pulse MIG, push-pull type gun to help minimize the bird's nesting of the aluminum wire, or possibly a spool gun. There are advantages and drawbacks to both, but those are some of the basics.
Okay, next question. Will my resistance welding equipment work on aluminum?
I look at the evolution of resistance welding equipment over the years, and it's impressive. The equipment that's available to our industry today, I think back over the years and I think, wow. But when it comes right down to it, when it comes to aluminum resistance welding, it takes a tremendous amount of current, substantially more than what we have available to us right now in the repair sector. So right now, resistance welding on aluminum for the repair sector is not a viable opportunity.
What are some of the tools and equipment that you would consider must-haves for a shop when doing aluminum repairs?
Yeah, I see so much of I'm going to say the basic tools and equipment are very similar to what we use on steel structures. However, we need to take and I'm going to say draw a line at a certain point and make some decisions on what can we and can't we carry over. As we take a look at our hammers and dollies and things of that nature, some of the basic hand tools, we're looking at, you're working with a softer material here in many cases, and we want to have tools that have polished faces, tools that are really dedicated for that aluminum repair that we're doing. We may find that in some cases belt sanders come in very handy for some of the surface preparation on some of the unusual areas that we have to access. Again, the riveting tools, depending on the type of rivet that we're dealing with. Knowledge is a very important tool, and your skill set is another very important tool. Hopefully, as you move forward, you'll take and involve both of those as well.
The aluminum grades seem to all fall within a fairly narrow band versus the high-strength steels. Will that narrow band be expanded upon, and does this limit its uses compared to the more versatile steel varieties?
That's an interesting question there, and I'm going to have to think about that one for just a second here. It really comes down to, and the words that resonate in my mind are the design intent of the material. Are they going to achieve what they're looking for? And so as I think about aluminum structured vehicles and their construction, one vehicle comes to mind very quickly, and that's the Audi A8, where they have incorporated inside of that aluminum structure, they do have some steel in the B-pillar, because they were looking for the properties of that piece of steel that it could afford, that it could provide, that the aluminum didn't. That's kind of a two-way street there, because I also think back to, there were several model years where the Audi A4, a steel structured vehicle, they utilized an extruded aluminum rocker panel reinforcement that was a multi-cell extrusion and the length of that rocker panel. So here's a situation where they kind of flipped it around the other way and said, look, we've got this steel structured vehicle, but so that we can afford the strength properties and the performance properties we're looking for, we're going to put this aluminum reinforcement inside of that steel rocker panel. So, interesting question. Thanks.
What about sectioning, such as quarters or even B-pillars?
That's really going to come down to the specific procedures that are applicable to that particular vehicle. As we take a look at this particular course and this particular presentation, it's really a higher level generic view of what we're dealing with here. We will have some opportunities where there may be sectioning allocations. In other situations, we may find that's not the case.
Why is there no kink versus bend rule? Does that mean if a part is kinked, it can possibly be repaired? I would think that if aluminum kinks, it would tear, crack, or break when straightened.
Yeah, and I'll step back to that for just a second, the kink versus bend. In a sense that with aluminum, what we've found is that the repairability of that which is physically buckled, bent, damaged is very limited. And again, this is where the technicians from experience start to understand what they can and can't repair. But the damage, say if we've got a frame rail and we've got a visible buckle that's going across a corner of that frame rail, it's probably not going to be very favorable to straighten that. Now, again, depending on the composition of that part. What we're probably going to be looking at is pulling and realigning the adjacent structure, getting the indirect damage out of that vehicle structure, and then looking at some sort of part replacement or sectioning procedure for that which is physically damaged. Again, we have to judge that on a case-by-case basis on how those components respond during the pulling and repair attempts, and then take and draw our conclusions as to what we're going to do in the final repair outcome of that vehicle. Something that comes to mind as I'm scanning here, small dents and things of that nature. I'll just take and interject here very quickly. Stud welders. Our traditional stud welders for steel will not function on aluminum panels. There are stud welders available for affixing aluminum studs to aluminum panels. They're called capacitive discharge welders. There are a couple of companies that manufacture that equipment. It is an investment that you need to take a look at very, very carefully if you're going to go down this road. I went to the New York Auto Show a couple weeks ago, and I was impressed by the number of aluminum closure panels that we're seeing on steel-structured vehicles. Again, this is something where we want to take a serious look at this and weigh out what our opportunities are here for the future. Okay, looks like for some reason we have a little bit of a technical difficulty on the audio end. I'm not too sure what's happening there on that side of it. So just real quick here, I'll kind of bring us to a wrap up. We thank you all for attending the webinar here today. We appreciate that. And again, if you'd like to take and view this in the archives, this will be archived at www.abrn.com/ICAR aluminum. Once again, that's www.abrn.com/ICARALUMINUM. Thank you all for attending. We appreciate your dedication and efforts to performing great collision repairs.